To start post-processing with Autumn AFP Viewer, you need to load thermlog file. Here we have a thermlog file, which is the output of the UOT and COT. This thermlog related to the UOT analysis. We click on it and wait until it loads into the software. So as you see, in this thermlog file, we have 4 tooling and we have 5 tapes. If you click on a process, you will see the informations of the process, including velocity, energy, and the rest. If you go to UOT initializations, you will see the initialization including all of the boundary conditions and the setting here. And if you go on each object, you will see that more informations of the object and the name tag and the rest of the information related to the specific object. So what we need to do is just to select the object that we would like to represent. For example, all of the objects. Here, I select all of the objects here, all of the toolings and tips. And then we can go to the plots. And the first one is the layup. So we click on it and click on Update Plots. So you will see this is the updated plots. You could use this rotation angle to check have a different view, or you could also go to the views and set a different views for the representation easily. And we have 700 steps here. As you will see that if I make it a label different views, yes. We see that this roller, yes, this line, which is a representation of the location of roller, will move. So I click on play. So this analysis includes the delay time. So when the delay times, some part which is not going to update will disappear here. And here we have again the updated temperature here. You see the progress on the roller and the new material will be built. So as you see in the views tabs, you see that we could select different views. But currently, as you notice that there are many lines here, so we like to go to the zoom and use the mesh ones. You see we delete and represent a mesh, and here we edge, we remove the lines. So if we select the edge is there. If we deselect the edge will be disappear. And you see now the progress of the roller, which is the position of it, and the new material, which place it on that. We could also use a perspective view, and we could use the exploded scene. So here is a Z direction along the thickness. So I'm going to use the exploded scene and select the Z directions and set the scale. You see that different layers which were represented here. So I click on OK, and you will see that the progress of the temperature per each layer. So as you see here, each layer has the temperature and each layer has heat transfer between each other. So you see that the whole conditions here. and this is the upper layer, which new material which be added to the system. The other plot that you can create is the global thermal. But before doing this, let's go to the object and reselect some object, and you will see the differences. Now we deselect all of the tapes. So only the selected object will be represented here. Or we could also go to the object and select only, for example, the highest tooling 4, and reselect the object. So only the conditions of this object will be represented during the simulations. You see that the progress regarding the steps per layer and the total steps here. So the next plot is a global thermal. The difference between the layup all and global thermal is that layup all will assemble all together, put it on top of each other, so the height should be different, would be on top of each other. But with the global thermal, all of the object will be represented at the same height. So if you click on it, it's actually the same plot. But if you select a couple of objects, for example, like that, all of the plots would be like superposed on top of each other. Was not actually on top of each other, would be inside each other. So if you only go to the exploded view, you will see the differences. And the question is why we have two plots, why we have layup all and global thermal. Well, the answer is that with the global thermal, you could select a point with the cursor, and you could extract the point. For example, if you would like to compare it with thermocouple data. And again, I go back to the object and select all of the object, and using this plot global thermal, and we see that hey, all of the objects are represented at the same height. And how about the local irradiation zone? So the local irradiation zone are the area which is irradiated by the laser. So I started from the first step, I click on play, and you will see that at this area, which is area here at the left side, we have the knee point, and this area which is irradiated here. So again, starting from step 1, click on play, you will see that the area is irradiated and the material flow at this direction, from right to left. And if we go to the next layer, you will see that the new layer would be on top of that. If I go a little bit further, you will see that this area, the new tapes would be placed on top of the previously laid tape. You will see here. And again, you could use different views to plot that. And you could go to the zone and using the different representations if you would like to have a equal axis or not. And of course, you could also use the exploded view to see all of the layers here. Another plot is that consolidation thermal. But before going to the consolidation thermal, let's have a look at the tape all. tape all actually is the incoming tape conditions. And for representing the incoming tape conditions in the irradiation zone, the only thing you need to do is to go to the objects, and until now we select all of the 2 links and all of the tape except the last tape for the local irradiation zone. But here we selected the last tape only, so tape 5. And we go back again to the plots and click on update plots. So you see, this is the conditions of the local incoming tape situation. So starting from the step 1. So these at the red area, the right side is a knee point. So as you see it again, irradiated and then reaches almost steady state situations. And we have until steps here, and again the new tapes situations here. And then there would be placed at the new tape. So it would be go to the new layer 2. So this is each time the new incoming tape is started, we have this plot like that. So to rephrase this again, for the local irradiation thermal, you need to select every object as you want except the last object, because the last object is object that is going to be applied on the rest of the substrate. Yeah. So this will be considered as a local irradiation thermal on the 2 links. And if you like to have conditions of the local irradiations of the incoming tape, you select a tape all and then select the last tape. The next item is the consolidation thermal. For consolidation thermal, is the area which is under the roller would be consolidated. Here we can select all of the object to see the situations. So you see here, this is the control volume representations. This area would be under the roller. We see how it works. We click on play. So it seems that there would be the inlet and outlet. The inlet coming from the local irradiation zone, and here there would be a press from the roller, and there would be boundary condition between the roller, and then from the other side would be the output. So the conditions after the consolidations. We will have a look again video representing the tapes. So here again, we will have a look how the situation start. So here, as you see, we have the more hotter spot at this side, and then less hotter spot at this side. So here we have inlet, here we have outlet. Here we would like to have a look on this object, how it works. So let's have a look again. Now, so we have an inlet here, as I mentioned before, and this is the situation. So this is end of the layer, and again we coming the new layer, and then the conditions under the roller. And this is based on the contour volume calculations. So these material are not represented. This material is actually moving, from one side to another side with a certain velocity that we define it into the process. And if you like to see the information regarding the temperature of irradiation zone, you will see it here. The maximum temperature, the average temperature, and for each sections. You could also represent it, show it, the information also in add-on plot, which is local irradiation thermal. So whenever you click on irradiation zone, the temperature of the average and minimum maximum will be represented here. The next plot would be the temperature along the thickness. So we will have a look. What is it? So this would be the plots, the temperature condition along the thickness at the knee point. So we select the right view to show it to you. So this seems like a good view. So we select all of the objects and selected the upper layer have a higher temperature, and there would be a temperature like that. And get the last tooling, which is tooling 1R in this analysis, was considered as a fixed. So as you see, we have the conditions of the temperature here along the thickness at the knee point. So with this information, we could estimate what are the temperature gradient at the thickness, and where could, for example, expect some phenomena based on the temperature gradients. And the next 2D plots are the temperature along the length. So from the left side toward the right side, which is the knee point. And for each object, we have the temperature conditions here. And the summary would be represented here. And the last plot would be the temperature along the knee width, which is along the knee point. So these are the plots. You could get the informations for all of these plots more by extracting the result like time series plot, which will be useful to estimate also crystallinity. We discuss it in another video because there would be much information regarding the extracting the informations from the time series plot information from the contour plots.